Hello students, today we are going to discuss board exam problem 2026 from chapter number 1 real numbers. So we start with the MCQs. So this is the first problem. Question is natural number 1 as option A prime number, composite number, prime as well as composite, neither prime nor composite. So natural number 1 is always neither prime nor composite. Second MCQ, the natural number 2 is prime number, composite number, prime as well as composite, neither prime nor composite. So natural number 2 is always a prime number. So option A is correct. Next question number 3. The HCF of 960 and 432 is. So to find the HCF, first do the prime factorization of the given numbers. First number is 960. So 960 can be divided by 2 table. So 480. Again divided by 2 table. It's 240. Again it's divided by 2 table. 120. Again it's divided by 2 table. 60. Again it's divided by 2 table. 30. Again it's divided by 2 table. 15. Now it's divided by 3 table. 5. Next number 432. 432 divided by 2 table. It's a 216. This number can be divided by 2 table. 108. 108 divided by 2 table. It's 54. 54 can be divided by 2 table. It's a 27. Now it's divided by 3 table. 9. Now it's divided by 3 table. 9. The prime factors of 960. So 960 can be expressed as 1, 2, 3, 4, 5, 6. We have 2 6 times. So 2 power 6 multiple 3 multiple 5. Next number is 432. So 432 is 2 power 4 multiple 3 power 3. To find the HCF, always we should choose the common factor with the smallest powers. So HCF of 960 and 432 is, first write the common factors. So common factors are 2 and 3. So smallest power of 2 is 4. Smallest power of 3 is 1. So 2 power 4 is 16. So 16 multiple 3. So HCF of these two numbers is 48. So option A is correct. Next problem. The LCM of 960 and 240. So first find the prime factorization of the given numbers. So 960 can be divided by 2 table. So 480. Again divided by 2 table. 240. Again divided by 2 table. 120. Again divided by 2 table. 60. Again divided by 2 table. 30. Again divided by 2 table. 15. Again next 3 table. So 5. So next number is 240. So 240 can be divided by 2 table. So 120. Again 2 table. 60. Again 2 table. 30. Again 2 table. 15. Now 3 table. 5. So write the given numbers as product of prime factors. So 960 is equal to, we have 1, 2, 3, 4, 5, 6. So we have 2 6 times. So 2 power 6 multiple 3 multiple 5. Next number is 240. So 240 which is equal to 2 power 4 multiple 3 multiple 5. Now to find LCM, we should choose all the factors. So LCM of 960 comma 240 is equal to, write all the factors. So what are the factors we have? 2, 3, 5. Write all the factors with the highest powers. So highest power of 2 is 6. Highest power of 3 is 1. Highest power of 5 is 1. So 2 power 6 value. What is 2 power 6 value? So 64. So 64 multiple 3 multiple 5 is 15. Now multiple these two value, 64 into 15. So 64 into 15 is 960. So our LCM answer is 960. So option A is correct. Next problem. For any natural number n, 5 power n ends with a digit. Option A 0, option B 5, option C 3, option D 2. So 5 power n. N belongs to the natural number for any natural number n. Okay. So let me check. 5 power 1 value is 5. 5 power 2 is 25. 5 power 3 is 125. 5 power 4 is 625. So 5 power n always ends with the digit 5. So option B is correct. Next problem. For any natural number n, 6 power n ends with the digit. Option A 0, option B 6, option C 3, option D 2. So we will check. 6 power 1 is 6. 6 power 2 is 36. 6 power 3 is 216. So 6 power n always ends with the digit number 6. So option B, 6 is correct. So next problem. 3 multiple 11 multiple 13 plus 3 is a prime number or composite number divisible by 13 or an odd number. Okay. Now we can find the answer for this question. So the given number is 3 multiple 11 multiple 13 plus 3. So this is a given number. Now this is one term. This is one term. From these two terms, what is common? 3 is common. So take it outside. So remaining we have 11 plus 13 plus 1. Now simplify this. So 3 multiple, what is 11 multiple 13 is 143. So 143 plus 1. Next again simplify this. 3 into 143 plus 1 is 144. So 3 multiple 144. Correct. Now find the prime factorization of 144. So 144 can be divided by 2 table 72 times. Again divided by 2 table 36, divided by 2 table 18, divided by 2 table 9. Now divided by 3 table 3. So we can rewrite this 3 multiple. So prime factors of 144, 2 power 4 multiple 3 square. Already we have 1 3. So 3 multiple 3 square is 3 power 3. So 2 power 4 into 3 power 3. Okay. Now listen. So this is a given number. Now the given number can be written in the form of product of prime factors. So by using the fundamental theorem of arithmetic, we know the concept. Every composite number can be expressed as product of its prime factors. So this number can be expressed as product of prime factors. So option C, it's a composite number, is correct. Next problem. Assertion reason question. The given assertion statement is root 3 plus root 5 is an irrational number. We know the proof. Root 3 is irrational, root 5 is irrational. So root 3 plus root 5 is also irrational. Root 3 plus root 5 is always irrational. So we can prove this. So the statement is true. The assertion statement is true. Now check the reason statement. The statement is sum of any two irrational number is always irrational. So we have to verify the statement is correct or not. Okay, if it is correct, we have to verify is this correct explanation for the assertion statement. Okay, so first check this statement is correct or not. Now listen. So sum of any two irrational numbers. So consider any two irrational numbers. We know very well root 2 is irrational and also minus root 2 is irrational. Now these two are irrationals. Now we can find the sum of these two. So just add these two numbers. So root 2 plus root minus of root 2. So the sum of these two is always equal to 0. But 0 is always rational number, is not irrational. Correct? But given statement is sum of any two irrational number is always irrational. So the statement is false because of this example. We got the contradiction example. So this statement is false. So this is false. Assertion statement is true. Reason is false. So which option is correct? So the correct option is assertion is true, reason is false. Okay. Now next assertion reason question. The assertion statement is HCF of 36 into m square and 18 into m is equal to 18m, where m is a prime number. So this is a given statement. So two numbers given, 36m square and 18m. So HCF of these two is 18m is given, where m is a prime number. M is prime number. So we can find the prime factors of the given number. The first number is 36m square. M is a prime number, so it is already in the product of prime factors. Okay. Now factorize this 36 can be divided by 2 table 18, again divided by 2 table 9, now divided by 3 table, so 3. Next number is 18 divided by 2 table 9 can be divided by 3 table 3. So we can write the first number 13m square as can be expressed as a product of prime factors 2 power 2 multiple 3 power 2 multiple m power 2, where m is a prime number. It's given the question. Next second number is 18 into m. So 18 we can write 2 into 3 square into m. Okay. Now listen, we should check the HCF value. So HCF of these two, HCF. How can you find the HCF? Write the common factors. What are the common factors in these two numbers? So 2 is a common factor, 3 is a common factor, m is a common factor. So to find the HCF, choose a common factor with the smallest powers. So smallest power of 2 is 1, smallest power of 3 is 2, smallest power of m is 1. Now simplify this, 2 into 3 square, 3 square is 9, 2 into 9 is 18, so 18m. So HCF value is 18m. So now we found the HCF. So statement, check the statement. Yes, the assertion statement is correct. This is true. Okay. Now move to the reason statement. HCF of two number is always less than or equal to the smaller number. Yes, this is always true. HCF of two number is always less than or equal to the smaller number. Okay. Suppose two numbers are given now. Your HCF value always always less than or equal to the smaller number from the two given numbers. So this statement is also true. Okay. Now verify the relationship between these two. The reason statement is correct explanation for assertion or not. Okay. Listen. The two numbers are 36m square and 18m, in which the smaller number is 18m. 18m is the smaller number. We found the HCF also. HCF is also 18m. So our HCF value, however, HCF value is equal to the smaller number, that is 18m. Correct? So this statement, reason statement, support the assertion statement. So option A in the board examination, the option A is correct. Option A is assertion A and the reason R, both the statements are true, and R is the correct explanation for the assertion. So this is the correct answer for this question. Okay students, is it clear? So till this one, the MCQ of 2026 board questions from the chapter 1 over. We will continue with the 2 mark and 3 mark in the next video. Okay, okay students, thank you.